Now let us see the different types of sets. First is null set, also called as empty set or a void set. Now it is a set which does not contain any element at all. That is called as a null set. And it is denoted by the Greek letter phi, or simply the empty curly braces, that is like this, right? The next we have what is called as the singleton set. Now here also, as the name suggests, singleton set means it is the set which has only one element in it. Now if you consider a set which consists of say 0 in it, so as shown here, it is a set having only element 0 in it. Remember that that is not a null set, although we may feel that 0 is somewhat similar to null or nothing, but that is not the case, because 0 is also a number and it has existence. So therefore that is an example of singleton set and not a null set. Next we have finite and infinite sets. Now here the classification is based on whether the number of elements in the set is finite or infinite. Accordingly we call those sets as finite or infinite sets respectively. The fourth type is the equal sets. Now here we have two sets and we call them to be equal if all the elements in both of those sets are exactly same or identical. So that means irrespective of order in which they are listed, the elements themselves are exactly same in both of the sets. Next is equivalent sets. Now here the number of elements in two sets are same. So that means how many number of elements are present in both of the set, that is matter. That means the elements themselves may not be same, but the number of elements has to be same. So therefore if we compare equal sets and equivalent sets, we can say that the equal sets are always equivalent, but the equivalent sets need not necessarily be the equal sets, right? So that is what derives from the definition of these two sets. Next is the universal set. Now here the universal set is the largest set in the context, that is based on what context we are discussing about, the largest possible set that we take for our reference is called as the universal set. So this definition is context sensitive and we will see in the examples that how can we decide what is a universal set. Now based on this, move ahead and let us see one more important type of set. Now that is subset, superset and proper subset. Now let's see one example here. Suppose I have say A as one set which is having only two elements as 1 and 2, and B is another set having elements 1, 2 and 3. Now A is called as a subset of B if all the elements of A are also present in B. That's the definition of subset. So here we see that all elements of A are present in B. Therefore we call that as a subset, and the subset is denoted in general as this symbol, that is A is a subset of B. So A is the subset of B and B is called as the superset of A. So it's a pair of a subset and its superset. Now then what is a proper subset? Right. Okay. Now let us compare the example which we saw above with a slightly different example. That is, here also let's consider A and B. A contains 1 and 2 and B also contains 1 and 2. Now if we ask the definition, is A the subset of B? Here we will find that yes, because all the elements of A are present in B also. So here A is the subset of B. Okay. But then what is the difference between the two examples, that is one written above and one written below? You will see that in the first example there is this element 3 which is extra in B as compared to A. Alright. So now in this case where we have at least one element extra in B as compared to the first set A, in that case A is called as not only just the subset, but it is called as the proper subset of B, and this is denoted as A proper subset of B. So the symbol is very much similar to the subset symbol, it's except that the horizontal line is not mentioned. Now whenever we are not sure about whether a particular set is proper subset of some other set or not, then in general we always write this particular symbol. Okay? But whenever it is known that the superset contains at least one or more additional elements, then we call it as a proper subset.